Okay, we're going to be looking today at section 13.6, using measures of central tendency and dispersion. Now, these are terms you may well not be familiar with, though you certainly have encountered the concepts of central tendency. And what do we mean by that? Well, the measures of central tendency are what we have always referred to in the past as some form of average. So let's make that note. So measures of central tendency, there are three: mean, median, and mode. If we can remind ourselves of how these are calculated or what they are, the mean of a set of data is all of the values added up and divided by the number of values. So if you've got a data set x1, x2, x3, up to xn, then the mean, and we write it like that, x with a bar over the top equals x1 plus x2 plus x3 plus ... x to the power n divided by n. So there is the calculation of mean. Median is the central value when the numbers are written in order, and the mode is the commonest value. Okay, so we're going to look at a specific example and see how to calculate these, and maybe which one is the best measure in any particular case. Okay, so let's look at a specific example. We've got the heights of 8 waterfalls in the state of Washington are listed below. What measure of central tendency best represents the data? So I think what we need to do is to work them all out, calculate all of the measures of central tendency, which are the averages. So the mean would be everything added together divided by the number of values, which is 8. So our mean would give us 1,344 units is feet. Okay? The median, and we just use the word median, is the central value. The numbers are already written in order, so our median value is in between those 2 points there, in between 1191 and 1200, and in fact it is the mean of those two values. So it's 1191 plus 1200 divided by 2, which gives us 1195.5 feet. And then the mode is the commonest value. We go back to our data set. Only one value occurs more than once, and so that would be our mode. And we look at these three measures, and we say, well, which one best represents the data? And what we mean by that is which one gives us the best idea of the heights of the waterfall. So we've got a very low value, we've got quite a high value, and then 1195.5 in the middle. And I'd say probably the median in this case represents the best. The mode, it's the lowest of all the values. So if you were to say the average height is 1,000 feet, that's quite clearly not true at all. And if you were to say, if you were to look and see where the median falls on the spectrum, the median is, sorry, the mean is somewhere here, which is quite a long way away from the rest of the data. So again, I would say that the mean is not a good representative, but the median itself is probably the best. Quite often this is the case, but not necessarily always. Anyway, I think we just need to practice calculating mean, medians and modes. So we're going to do that on page 877. There are problems 3 through 8. Just spend 5, 6, 7 minutes doing these. And there we are. Okay, great. So what we're going to look at now is the next component of this particular chapter, which is the measures of dispersion. So let's go and look at that. The measures of central tendency look at the average, the middle of a set of data. The measures of dispersion is a look at the spread of the data. And there are two different ways of thinking about this. The first is something that we have encountered before, something called the range. And the range is an easy calculation. It's the highest value minus the lowest value. Okay? A nice, simple concept. The next concept is less simple. It's called the mean absolute deviation. And it is calculated like this. If you have a set of data, x1, x2, up to xn, the mean absolute deviation is the absolute value of the distance between each data point and the mean of all of the data points. You add them all up until you get to the last one. And you divide by the number of values. Okay? Quite a complex calculation. Really, it's best explained by doing a specific example. So let's look at that. So we're just going to take the data from the last question, we just completed question 8, and we're going to try and calculate try and calculate the mean absolute deviation of this. The first thing we need to do is to work out what the mean is. So the mean of the data, you've probably already calculated it. 8 plus 360 plus 333 divided by 6, and that equals 333.6 bar. Okay. Now, so the mean absolute deviation is each of those data points, is the distance from each of those data points to that mean. Okay, let's try and work that out. So the mean absolute deviation equals, first point, 300 minus 333. I'm just going to put 0.7 for the sake of brevity. 320 minus 333.7 plus all divided by the number of values, which is 6. Okay, so I'm going to just do that calculation quickly. Okay, so there's my calculation. Each component, so the 33.7 comes from here, 13.7 comes from here, etc. Okay, we add up those values. They're all going to be positive because we're looking at absolute values, and we divide it by 6, and we get adds up to 96 over 6. So our mean absolute deviation equals 16. And this is a measure of the spread of the data. Okay. So I think you need to do some of these problems. We're going to be working on page 877. And there's questions 11 through 16. I'm going to include them below. And there they are. Great. All right, there are some word problems towards the end of this chapter, which are here. Question 19. 20. 21. and finally 22. Fantastic. Okay, complete the homework, submit that, and on to the next unit.